Hey there, it's Jason Gorman from Codemanship with a video on some advanced code craft. We're going to be looking today at a practice called continuous inspection for JavaScript developers. Now, this is a term that you might not have heard before. You may well have heard the term continuous testing, though. So the idea of continuous testing is that we're constantly retesting our code, sometimes these days even in the background. So your IDE, for example, might be running the tests whenever your code compiles in the background there. And we're able to do this, of course, because computers these days are much more powerful than they were 20 years ago. So whereas once upon a time running the test was a big deal, it took a while, now they can actually be run in the background and we can get real-time feedback as to whether or not we're breaking our code. And that means that we're being alerted to broken code, to bugs much, much sooner when they're much easier and cheaper to fix. So if we want to be confident that our code is continually working, continuously shippable for continuous delivery, then continuous testing is a prerequisite for that. You need to be continuously retesting the code. Similar idea when it comes to code quality, though. So yes, it works, but is it maintainable? So we're beginning to see this new discipline become much more popular these days, and there's all sorts of tools are emerging, and we're going to look at a couple of them to allow us to review our code on a continuous basis as well. There are many teams out there who have, as part of their check-in process, there's a code review required. So for example, if you're working on Git, they might have to submit pull requests, and someone else in the team or some kind of technical authority would need to review their code just to make sure that it's okay before it gets merged into the trunk branch. And that's to protect the code from protect the code base from bad code getting in. But that, as with all manual testing, has severe drawbacks. One, it doesn't scale very well, and I meet a lot of teams who report that pull requests in particular have become the bottleneck in their process, that waiting for someone to review their changes is becoming a bottleneck, and for larger teams or distributed teams, that can become a major issue. Also, like all manual testing, it misses a bunch of stuff. It is not exhaustive, it is not comprehensive, doesn't cover a lot of ground. And you are very reliant on the person doing the code review. So if your code is being reviewed by a relatively inexperienced developer, maybe they've only been working for less than a year. I've worked with developers all the time whose sort of sense of code quality is not as well developed as more experienced developers. And to be honest, I've worked with some very experienced developers who also don't have much of a sense of code quality, but that's a different video for a different time. But code quality often means different things to different people, and a lot of developers do not have that awareness. For example, I paired with someone a couple of weeks ago who had copied and pasted some code 20 times in the same file, and I sort of said to them, do we see any problem with that? And I don't think they were being facetious. I genuinely don't think they thought it was a problem. So then we had to have a conversation about duplication of code, the chances are that when your code's being reviewed, people will have certain blind spots, if you like, when it comes to code quality. They might not be aware, for example, of the principles of modular design. A lot of developers don't learn this stuff. So your code reviews are only in the same way that your code is only as reliable as your tests are. Your code reviews are only as reliable as the code reviewer. And the less frequently we do them also, it's the batch size problem again. It's a bit like if we only check in once a week, we're going to get loads of merge conflicts. If we only review code every few days, or once a week, or however often we're doing it, we're going to build up a lot of problems, a lot of issues, and most of those, let's face it, are not going to get fixed. Once you've delivered something, if you're then told that you need to go back and fix these 25 problems, and you're thinking, well, that's going to take me another day or two, probably not going to happen. So what you want is really early feedback, and you want it to be applied consistently and comprehensively to everything as frequently as possible. And as with functional testing or logic testing, we found the secret to that is to automate those tests. No different for code reviews. The secret to scaling up code review and making it more effective, and the secret to making sure that your code is always maintainable, is always of a high quality, is as much as possible to automate those code inspections. So that's what we're going to be looking at today. We're going to start by looking at a tool that is available if you're using WebStorm. So many IDEs have these tools now. So this is one that's built into WebStorm. And to demonstrate this tool, what I've done is I've cloned a copy of the one of the projects within the NPM GitHub space called CLI. So it is a non-trivial piece of code. It's tens of thousands of lines of code. And what I want to do is I want to be able to review this code for any potential quality issues. And I would like that review to be as comprehensive. So it's going to review everything, all of the code, every file, every function, every variable, every parameter. And I want it to be quick. So what I'm going to do, using the built-in functionality that comes with WebStorm, is I'm going to analyze all the code in the lib folder inside the CLI project, which is where most of the JavaScript is. So I'm going to inspect this code. I'm going to ask it. So we got choice. We can do the whole project, and WebStorm will not just analyze JavaScript code. It can analyze HTML and XML and CSS and all sorts of other languages as well. But I'm just interested in what's in the lib folder. And I'm going to choose the inspection profile. So this is the rule set, the set of code quality rules that are going to be applied to this code. We'll talk a bit mechanically how that works in a minute. So I'm going to click OK, and what it's going to do, it's going to crunch through all of this code, thousands, remember, tens of thousands of lines of JavaScript. We'll see it, off it goes there. And we'll see how long that takes. Typically less than a minute. And we can see already that lots of errors are being reported. These are code quality bugs. So they're not saying the code doesn't work. They're saying this piece of code has a problem in some kind of way. It could be a maintainability problem. It could be a security vulnerability or something like that. And we'll take a look at the kind of rules that it's applying as we go. So it's done already. So it reviewed all of that code for many, many rules, many dozens of different code quality rules and standards. And then it spits out a report at the end. Let's take a look at these errors. So we're getting different kinds of severity of message here, severity of problem. Typos, not too worried about those yet. Let's take a look at some of these JavaScript errors. Okay, so these are about the complexity of functions in our code, something that I feel very strongly about. Let's take a look at an example. So it's saying here, for example, in this bit of code here, it'll take us to the code. And it synchronizes in the editor as well, so we can fix that very easily. It's saying this function here is too complicated. Do I agree? Let's take a look. Yep, I agree. I definitely agree. If statements inside switch statements, and too many if statements and too many cases. So what this is measuring is what's called the cyclomatic complexity. That's the number of different sort of control flow paths through this function, and it's saying there's too many. I think we set the limit at 5. That's 5 potential different paths through a function beyond which it will throw up an error. And it's finding lots and lots of these. Now, here's the thing, of course. Take a look at that one. Again, I agree that too many branches in that code. So that code is it's more likely to be broken. It would be much easier to break that code. It'll be harder to test that code. It'll be harder to understand this code. And so for all those reasons, I think functions should be considerably simpler than this. Now, obviously, the people working on the CLI project have a different standard. They believe that complexity, the bar should be set somewhere else. As we'll see, they are also using a kind of continuous inspection, a kind of automated code review. So theirs must be set to allow this through. I would set it so that it doesn't allow this through. I would say, no, this is an error. You have to fix this. You have to refactor this code. And that's very, very important. Out of the box, WebStorm comes with a bunch of rules that we can just apply and go, well, let's just do what WebStorm says we should do. But then that requires us and JetBrains to agree on what the standard should be and where the bar should be set for code quality. And that's not going to happen, is it? That's just not going to happen. Teams will have their own ideas, and it's very, very important that the rules they apply to code are applied with a consensus that they've reached, and we'll talk about a process for reaching that consensus in a while. So these are JetBrains rules out of the box, apart from a couple that I have switched on and configured myself. But for the most part, they are the rules that were switched on out of the box, the project default rules for WebStorm code analysis. Not all of which I agree with, not all of which I'm interested in. And as you see, there's a whole bunch of rules. Let's take a look at the profile here, all the different rules that could be applied. There's a lot of them. A lot of them are switched on. Some of them are switched off there. So a lot of rules. So this is the list of all the rules out of the box that we could be applying to our code using WebStorm. Let's take a look at the two that I switched on, which are about function complexity. So we can switch rules on and off, so whether they're applied or not to our code, out of the box, just by checking and unchecking. We can also configure those rules to some degree. For example, how severe a problem is it? I think that if a function is too complicated, then that's an error that needs to be fixed. We can decide what to apply it to all the project files, or just the files that are open, or, very popular, just the files that we've changed. So if you're only interested in applying code inspections to code that is changing or to new code, then we can do that using this tool as well. And most code inspection tools have that ability. So for example, if you inherit a code base and you decide to start running code inspections on it, there's going to be lots of issues, and you're thinking, well, we know those issues are there. We know where the bodies are buried, as it were. But what we're really interested in terms of check-ins, for example, is there anything bad about what we've changed or what we've added? Is the code that we're changing good enough? So we can apply it just to that scope. I'm applying it to all in this case. And for some of these rules are like, yeah, all or nothing, either is or it isn't. Some of them, there are numbers involved. There's some kind of metric or measurement. For example, the cyclomatic complexity of a function. And I have set the limit at 5. I would guess that the other teams might say 10. I have seen some code bases that have, I won't say the name of the tool because I don't want to embarrass them, but there is a tool in the .NET space that's been around for quite a while, where they have set the recommended maximum complexity of function at, I think it's 50 branches in that function, so huge basically. And I think the reason they've done that is because what they did was they wrote the code for this particular code inspection tool, and then they turned the tool on itself, and then discovered that they'd written some very, 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 very big functions. And rather than go, oh, are we going to fix all of that and refactor all of that? What they did instead is they just moved the goalposts. Don't do it that way, by the way. Here's a tip. If you're writing tools that are about code quality, use the tool on itself and make sure that you set the bar where it needs to be and that the code you're writing for your tool is below that bar. Otherwise, yeah. So I think 5 is kind of my limit. I get quite uncomfortable when it goes above that level of complexity. So we can configure our rule sets in that kind of way. And using WebStorm, and there are other tools available, we'll see another one in a minute. Using WebStorm, we can run code inspections on code that's changed, or all of our code, as you can see, even on large code bases, very quickly, many, many times a day. And here's the thing, let's just explain how these tools work. So what WebStorm is doing, what their code analysis tool is doing is it's parsing the code and producing what's called an abstract syntax tree, which is just essentially a data model of the code. So it contains the things that are in the code, like the functions shrematch and the parameter AA and the parameter BB and so on and so forth. So it creates a tree model of that structure. And then it walks down that tree, and there will be rules that can be applied to each kind of node in the tree. So what rules apply to a function? For example, the name of the function, or the number of parameters, or what rules apply to parameters? What rules apply to if statements? What rules apply to for loops? What rules apply to blocks of code? What rules apply to expressions, and so on and so forth? So build a model of the code, and then it applies rules to each node in the code, different rules for different kinds of nodes. And in doing so, it's incredibly methodical. You could have dozens and dozens of rules, and you could have a very large code base, and it doesn't miss a trick, basically. It applies all of the rules that are switched on to all of the code. It's very, very scalable and very, very methodical. It doesn't miss things. So that's a really useful tool to have on your desktop. It's essentially a code review happening over and over and over again. Of course, you need to put some work into that rule set. If you just take it out of the box, what happens is there'll be a bunch of rules in there that you agree with, and there'll be a bunch of rules that you disagree with, and a bunch of stuff you just don't care about. And that will produce results that you don't put a lot of faith in. You go, yeah, we know it says that's a problem, but we don't think it's a problem. Or that it's missing stuff that you would think was a problem, that it should be catching, but it's not. So you do need to work as a team to develop that rule set so that it is something that, number one, you have consensus on as a team, and number two, you're finding it useful and effective as a code review. And that doesn't happen out of the box. You need to invest in that. Also, you will discover, for example, in the built-in set of rules for WebStorms, as far as I could find, there are no rules about object-oriented design, which I think is a little strange. But you will also find that most tools, there will be rules missing, things that you believe are bad. It's not just a question of it's switched off. It's just not there. It's not there in their default set of rules. And as we'll see in a minute, for that, you need to go a little bit further. So there's a new skill set involved in learning this. So there's a bit, that's why I say this is advanced code craft. This is going to involve a new set of skills. So there we go. There's a code review, a very big code review done very, very quickly. We don't necessarily agree with all of the results, but that's because I have not sat down and gone through and really thought about and worked on the rule set. If I had a good set of rules there, then I would be running these many, many times a day. And that would be catching problems as soon as they appear. Indeed, these days, you take a look, for example, here. This is underlined in red, so the editor is complaining that this is an error. And if we take a look at that, it's actually telling us in the code there, live in the editor. And what we're seeing now as our computers get more powerful is it's becoming possible to run this kind of static code analysis in the background, like we're beginning to run our tests in the background. So the Roslyn compiler for .NET, for example, has code analysis steps built into it. You can add rules to it. So as well as telling you whether or not your code is well formed, whether it will compile, it can also, live as you're typing it, say, right, that function's now too complicated. And you'll get that red squiggly line. And you can even potentially get the option to fix it automatically. So, and that you can get in WebStorm as well. For some of these rules, it is possible to also include an automated refactoring that will fix it for you. So that level of feedback, the speed of that feedback, the frequency of that feedback is coming really, really fast now. And I predicted this was happen more than 10 years ago when I saw the rise of continuous testing tools like JUnit Max for Java, for example, and NCrunch for the .NET platform, tools that will run your tests continuously in the background. And I thought, can't be long now before they're also continuously inspecting the code in the background. So you're getting that feedback straight away. And that means that we're having problems pointed out to us as soon as they appear and not a day later or a week later or a month later, when the chances are there's going to be 100 problems and not just one, and most of them are not going to get fixed. It's that same old problem that the longer we leave it before we discover the problem, let's call these bugs, code quality bugs, the longer it is before we discover the bug or before the bug's reported, exponentially the more it's going to cost to fix, because we've moved on. It's going to be a big deal to go back to code that we thought we'd finished maybe a day ago or a week ago or however long ago it was, and then start refactoring. And we all know that we never get that time. We never get that time. So this is a way of achieving high quality code, but avoiding the level of kind of technical debt that usually means it's never going to get addressed. People are not going to go back and fix this stuff. Okay, so that's the basic idea of continuous inspection. And there's one tool that we can use to use that. If you're not using a full-blown kind of IDE like WebStorm, don't worry. There are other tools available. Let's take a look at one. We'll go to their website. No, that one, that's the one I was about to look at. This is the one we're interested in. So let's just quickly go to their homepage. So a linter basically is a tool that does exactly what that WebStorm code inspection tool does. It builds a model of the code using a parser, for example, builds an abstract syntax tree. It walks down the tree, and then there's a set of rules that it can apply to each node in the tree. We can take a look at the rules come out of the box with ESLint. Other linters are available for JavaScript. And this is essentially just a command line program you can run in your code. So let's go to the rules. So there's a list of rules that we can perform. Blah-de-blah-de-blah out of the box. Some are turned on by default. You can see which ones are turned on by default. And we can configure. How do we can configure the linter? We go down to, we say which parser to use and other technical stuff, environment variables, et cetera, et cetera, et cetera. So for different versions of JavaScript, for different platforms and so on. Globals, global. And here we go. We configure plugins, so we can write our own stuff for this. We'll talk about that in a minute. And then down here, configuring rules, basically similar kind of thing. We can turn rules off or on. We can say whether or not a code, you can say here for our command line, an exit code of 1 is triggered. In other words, we could put this command line version of ESLint into our build pipeline. And if it returns with the code of 0, we say it's got through that inspection. But for errors, if we say this particular rule, if this fails, it's an error, then it will actually return with a code of 1, which means it's failed, which means you can then fail the build automatically. So this can become part of, as we'll discuss in a bit, a quality gate as a last line of defense to stop bad code getting into your code base. But it basically does pretty much the same thing as the WebStorm tool. Indeed, the WebStorm tool allows you to also add ESLint as part of their analysis. So a lot of these tools can kind of work together. But the same kind of thing. And for those rules that don't exist, for the stuff that didn't come out of the box, you look at the developer guide, you can write your own rules and your own plugins as well to work with different technologies and different languages and all that kind of stuff. But the basic idea is that rules are applied to, let's take a look, to a context. And the context is the type of object in the abstract syntax tree that we're talking about. Is it the whole program? Is it a function declaration? Is it an arrow function? Is it a class declaration, etc., etc.? And then we can implement a rule that basically is written against that type of node object. Let's take a look at an example of a rule. There we go. So there's your rule. So if our rule, for example, is you're not allowed to call things foo, I think that's a very good rule. You're not allowed to call things foo, then we could write a rule that applies to identifiers, to any kind of node that is identified, like the name of a class or the name of a function or a field or something. And then we can say, what is the name of that identifier? If it's foo, then we say, well, that's failed that particular test. And we would have a bunch of these. So it takes a bit of getting used to, but this is actually beyond writing automated code analysis rules, your own custom rules for things like ESLint, and you can write them for other tools as well. I actually find that it is useful to learn how to do this, because if we go back again to our list of node types in our abstract syntax tree, so if you work on software for managing a hotel, that software has what we call a domain model. So there's a hotel, there are rooms, there are bookings, there are guests, and et cetera, et cetera. Well, code also has its own domain model, and it is a very useful domain model to understand. As computer sciencey as it might sound, understanding the structure of programs and the structure of programming languages is very, very important, because sometimes we need to write tools, we need to write code that is about code. And these custom ESLint code rules are examples of code that is about code. And that tends to, number one, make you more useful as a developer, because you can start to write your own tools, for example, using reflection or using parsers, always there, always an option. But it also tends to make developers better at reasoning about code, in the same way that learning the domain model of a hotel makes us better about reasoning about the running of a hotel, because we know what we're talking about. We know what a reservation is, and so on and so forth. So it's the same thing with code here. So this, for many developers, this is a relatively new skill set. They've maybe not done this before. So they've written code, but they've not really thought about the structure of code that much. And so this does come with a bit of a learning curve, but it is a learning curve that is worth working through because it can be applied in all sorts of different ways and not just code analysis in this kind of way. So there you go. There's ESLint. It does exactly the same job in many ways in exactly the same way as the built-in tool in WebStorm. You can run it on your command line, so you can run it as part of a build, or you can just run it on your desktop from your terminal window as often as you like, and it will give you similar kinds of results. It, of course, it can be integrated into WebStorm, for example, and other tools. That's relatively straightforward to do. But if you are running it just at the command line, obviously you don't get all the extra stuff like automated refactoring and that kind of thing. But that's a nice to have. But these are the kind of tools that many of us have been using for many years now. Linters have been around for a long time and come in many, many flavors, but they all kind of work in the same way. Parse the code, build a model of the code, apply a bunch of rules to each node type in the model, and then produce a report at the end, results based on what your policies are as to what happens when each of those rules is broken. You know, is that something that should fail the build, or is that something we should warn about, etc., etc.? So all of this points to something that is a bit more complicated than just buying a tool or downloading a tool and switching it on. There's a whole process around continuous inspection, particularly about the design and the maintenance of what we call our quality gates. Quality gates are the whole thing put together, the rules and the policies that we apply when those rules are broken. And then finally, there will be a set of criteria as to whether or not we say that has passed the inspection or whether we say it's failed the inspection. And we can make our quality gates hard, like, you know, nothing can get through. We can make them soft. And a lot of the art of it, if you like, of continuous inspection is designing your quality gate so that it's just right. Get in that Goldilocks zone that just forgiving enough, but not too forgiving, that you're not letting in the really bad stuff. So as an early warning system, these things are great. But a lot of teams also build them into their continuous delivery process as part of their build pipeline as a last line of defense against bad code, essentially. And in many cases, as a partial replacement for pull requests. So the better you are at code inspections and automating them and designing quality gates, the less you tend to find you need pull requests or you need to rely on them. And as we'll see at the end, that doesn't mean we don't review code or that we totally rely on these automated checks, but we need it less. We can rely on this stuff more. We can lean on it more. And because it's faster and more scalable, we tend to find that can make a big difference. So there's ESLint. Many other linters are available, but they all work pretty much the same way. Okay, so as part of this design process for continuous inspection, let's talk a little bit about that. So you're a team and you're going to be working on a new code base and you think, well, we should start as we mean to go on. Let's set up continuous inspection from the beginning. Now, let's say we're starting to begin with from a blank slate. So maybe we're a new team and these are new tools and et cetera, et cetera. So starting from a blank slate, what would we do? Well, the first thing I would do is I would get everyone around a laptop and start looking at code. So get a laptop and a projector or a big screen, go in a space or a room somewhere, get the team together and start doing code reviews, real code reviews. Look at real code, maybe code from previous projects, maybe code that you've cloned off GitHub, for example, and start having that conversation early about what you like about this code and what you don't like about this code. That's the beginning. Using those examples, it's very important to use real examples. Don't sit in a room and have a kind of an abstract discussion about good code and bad code. Look at real examples of code and go, do we like this? Do we not like this? What don't we like about it? And et cetera, and begin to build up those examples and to start to reach a consensus on what your set of coding standards probably needs to be. Start small with just a few. Start with the basics. I always find that I immediately go to basic design principles. So I always look at complexity as the big one, duplication and dependencies, couplings, basically. So we typically start with maybe a dozen rules that are about those very basic things. And we would not just sit down and go, how many couplings are too many? we would look at code and see, do we think that's problematic, or did it prove to be problematic? And we'll begin to feel our way using those examples. And if you think about it, that's the same design process that we would do for if we were building software for a hotel. That's what we would do for a hotel. They would say, well, what are our goals? Okay, those are our goals. Right now, show us some examples. Let's explore this domain. Let's look at some example. Maybe go spend some time in a hotel. Maybe work in a hotel, or stay in a hotel and start collecting these examples, and then go into a room somewhere and review those examples and go, is that how that's supposed to work? What's the rule there, etc., etc., and begin to build that domain understanding. And that's exactly what we're doing here. It's just that our domain now is the code. So use examples, look at real code. Very importantly, do it as a team. You need to get buy-in and get that consensus. Don't be over enthusiastic about this. Don't have too many rules. As we'll see, this doesn't replace judgment. You don't have to think of everything. People still have brains and can make decisions. But you need to be thinking about where does the bar need to be set? What's the stuff we really need to? What's the stuff that start with? What should definitely not make it into the code base, and start there. So start to build an understanding, and as you do that, you can begin to build your rule sets, either using out-of-the-box rules, switching them on and off, and configuring them to taste the way you want it. How many sugars do you like in your coffee, basically? How complicated a function is too complicated? And start to configure that. And if there is a need to, you might also want to maybe write a couple of custom rules for stuff that the tool leaves out. And that's going to take you a bit longer, but if you're skilled in that, it won't take you that much longer. It might take you a few days to develop those custom rules. And then once you've got those, you ain't done, because we're never done. We're not going to be done with our hotel software just because we've done one delivery. You come up with your first rule set, your first attempt at a rule set, and then you test it. You test it on real code, test it on your code, and then you feed back. Okay, there's some stuff getting through that we don't think should be getting through our quality gate. There's stuff that's being stopped that we actually we don't think is a problem, or it's more nuanced than that. So maybe that's the stuff we should downgrade from an error to a warning that you have to review it, or something like that. So you kind of learn as you go, and over the weeks you will tend to find that your quality rules, code quality rules, and your quality gate starts to stabilize and starts to become more useful. The good news is, once you've done that once for one code base, a lot of that effort can be reapplied, reused on other code bases. So it is worth making that investment up front. You don't have to do the whole thing in one go. So spend some time on this. Typically, we find that the good development teams are investing 20 to 25% of their time in this kind of activity, tooling, as we call it. So if you've got 4 developers on your team, maybe on average, one of them will be working on this at any point in time, particularly in the early parts of the project, to get all that stuff set up, just like they need to get their builds pipeline set up and their delivery, their release pipeline, and so on and so forth. There's a lot of stuff that you're going to be working on in terms of tooling and yak shaving, as we call it. And this is just another one of those. So it is a design process. You're creating a piece of technology, a piece of software. Even if you're reusing something out of the box, there's going to be some level of configuration and customization involved. And therefore, you need to do that in a test-driven way, in an example-driven way. You need to involve everyone who needs to be involved in that process. Don't just have your technical architect go off and design a set of rules for you, because that way much sadness lies. People basically don't apply other people's rules. So you need to get that buy-in. You need everyone to be involved. It is a great opportunity also to have those conversations early. The worst time to be talking about code quality and architecture and all that kind of stuff is downstream, because by that time a whole bunch of code has already been written, and then you've got a bit of a problem. So the best time to have that conversation is up front, as early as you can, as a team. So you design your quality gates, and then the question is, how do you apply them? You can apply them like I do with my unit tests on my own desktop many times, just every few minutes, run the test, run the test, run the test. And when I have continuous inspection running, I'm doing a similar kind of thing. Okay, I've done a bit of refactoring there, let's inspect. I've done a bit of refactoring, let's inspect. Typically, I have it switched on that it's only inspecting changes. And it's doing that continuously. So as I'm changing code, it's going, okay, now that's too complicated, and et cetera, et cetera. And I'm getting that feedback straight away. Don't forget, I'm also a human being with what amounts to a brain, what's left of a brain after the best part of 50 years. And I can exercise some judgment. I'm also a very experienced programmer who thinks a lot about code quality. So without continuous inspection, even if I say so myself, the code I write is pretty high quality. It's pretty maintainable. But like all humans, I'm fallible, believe it or not, and I miss stuff. I miss stuff all the time because I'm programming, or maybe we're pairing, and they're thinking about a bunch of stuff to do with, well, how do we do this with Node? How does that work? What's the keyword? Let me just Google that. What's for lunch, and et cetera, et cetera. So our brains are full of other stuff. And one of the real benefits of automated inspections is they're not thinking about what's for lunch. They are exhaustive, and they can cover a lot of ground with a lot of rules very quickly, and they don't miss a trick. Provided, of course, you have the right set of rules, and that's the hard part. The other way that teams I've worked on have applied automated code inspections is as a last line of defense to stop things from getting into the trunk that shouldn't get into the trunk. So they would incorporate into a build. It's very easy to incorporate a tool like ESLint into your build. But in larger teams, or in teams of teams, or large companies that have many, many teams, as it is with build automation and continuous delivery, you might want to create some kind of framework around that makes it managing lots of these things, lots of these projects, much easier. In the same way that GitHub has been built around Git, so that it offers a lot more in terms of build integration that you can do at a touch of a button and stuff like that. There are tools that are available, platforms that are available, that build a similar kind of thing around code analysis. And one of the ones I wanted to show you is a tool called SonarQube. So we'll take a look quickly at their website here. There we go. Code quality and security. So this does continuous inspection. It's a continuous inspection platform in the same way that GitHub is a version control platform. Or Circle CI is a continuous integration platform. It's not cloud-based as far as I know, so you can download a free edition of it, and that runs with a local proprietary database, so it doesn't scale very well. But you can use the commercial version of it with database platforms like SQL Server, so it can scale up to many, many teams and many projects. And it works with many, many programming languages, and it brings it all into one place, how we manage it. So let's take a look at my dashboard, my project dashboard. Where are we? Here we go. My project dashboard. So it's running on a local web server here. I've done a bunch of analyses here. Here's the analysis for that CLI project, the NPM thing that I showed you earlier. We get a nice, easy to read summary of it in terms of code quality. Bugs, it's found some probable bugs there. It's failed its security review there because I think because in the tests, there's a lot of code that's got hard-coded logins, and it's spotted that. It's found a lot of code smells, but none of them are bad enough that it thinks they're really a problem. So essentially, based on this review, and also we can bring in code coverage, test coverage reports and incorporate those as well. It's saying overall, though, that this is okay. It's got through our quality gate. So this will be built in as part of our continuous integration process, as part of our build pipeline. Let's take a little closer look at this. So very similar to the kind of reports that we get from other tools like ESLint and etc. They've interpreted it a bit more in terms of, for example, these nice little easy red, green, blue kind of things that are easy to understand. Found lots of duplicated code, but it doesn't think it's a problem. And we take a look at the code smells here. There's a lot of low-level stuff, a lot of which I wouldn't necessarily particularly care about, for example, shadowing variables and stuff like that. So we don't think it's particularly bad. So this makes it through. So if I was working on CLI and this was their quality gate, this would get through the gate, basically. Now, how do we configure all of this for each of our projects? Well, we can configure the rule sets. For example, for JavaScript, we've got a whole bunch available there, potentially. And we can see what rules are available there. We can find out more about them and see a little bit of documentation and stuff. We can create our own, just as we can do in WebStorm and we can do in ESLint. We can create our own rule sets, our own quality profiles. So here's, for example, the codemanship way for JavaScript. So this is my copy of SonarQube's built-in rules. And we can activate rules just like we were doing in WebStorm. Let's find one. Failed unit test should be fixed. I totally agree. So we can activate that. And just as we can do in WebStorm, and as you see, we can do in ESLint, we can say how big is, well, I think if you've got failing tests, that's a blocker. In other words, this would fail. So I'm going to activate that. If you've got any failing unit tests. And so on. So we can construct our own rule sets. Just as we can with ESLint, we can write our own custom rules and plugins as well. So we don't have to just take what comes out of the box. So we create our own quality profile. We can go to any particular project and say, what is the profile that we wish to be applied to this particular project? So we can go into configuration for our project settings there. Which quality profile? And because projects may involve multiple languages, we can have different profiles for different languages in the same project. So it's all very convenient, just in the same way that GitHub adds a lot of sugar to using Git on teams and on distributed teams for open source. Similar kind of thing with SonarQube. It adds a lot of nice, friendly stuff on top of our code analysis. Let's go with the codemanship way. We've updated our profile there. So now it's obeying my rules for JavaScript. And we can also set up a quality profile here. A quality gate. So these are the quality gate for our codemanship gate, the Sonar way built in. So this is what will determine whether or not something gets through a build or whether it gets rejected. And if we want to, that's the built-in one. There's my codemanship gate. So I'm saying there should be no critical issues at all. If there are any critical issues in the code review, basically this will fail the build, and that person will have to fix those problems. We can add more conditions, for example, on new code, coverage of tests. If it's less than 95%, again, that will fail the build. So we're sort of saying what's allowed through the gate, what's not allowed through the gate. So very, very similar to what we're doing with ESLint. Indeed, you can probably get plugins that allow you to use other analysis tools as part of this. It brings it all. The thing I like about SonarQube and platforms like this is that, like GitHub, it kind of brings it all under one umbrella. And it scales it up very nicely to large teams and lots of projects and lots of languages and lots of code bases, but still gives you that overview in the same way that build monitors. A lot of large IT departments and teams now have build monitors that are monitoring multiple projects, multiple code bases, multiple branches, but it's all brought under one roof, so you can sort of get a 10,000 feet view of that, if you like, an at-a-glance view of what's going on with code quality and that kind of thing. So I do like that kind of thing. But under the covers, it is effectively doing a similar kind of thing to ESLint and to the built-in tools with WebStorm. Now, the last thing I want to say about this before we round out this video is I've been doing continuous inspection for quite a while now. And it can be very, very effective. There is quite the learning curve to it. So that's why I'm kind of filing this under advanced codecraft. But I think that learning, those skills and that knowledge can be reused in surprising ways, particularly when it comes to writing tools for developers, which we sometimes have need to do. I also find that it is a very useful practice because it encourages teams to have these conversations and to have them early. And that's a very useful thing, because the worst time to find out that we don't agree on what's good code and bad code is when we've written up thousands of lines of it already. And in terms of the process itself, this can be done in an example-driven, iterative way, just like any other piece of technology. And it can be driven by your needs, your goals, your code. You don't have to take just what you're given. In fact, I strongly recommend that you don't. Whether it's what the tool developer said, this is what we think quality is, or whether it's what your architect says, this is what quality is. It's very important that you reach that consensus. This does not replace the need to think about code quality. It does not replace code reviews, but it shifts their purpose. So code reviews now are not about testing the quality of the code, Code reviews are about having conversations and reaching consensus on the rules, on your quality profiles, and on your quality gates. So they serve a different purpose. So you would have them less frequently. You would have them as a team, and they're much more about the design of these quality gates than they are about actually inspecting code, because that doesn't scale very well. This doesn't replace pair programming either. Two people working together, and that's the reason why I'm not a big fan of rule sets that are huge, hundreds and hundreds of rules, because that kind of implies that people are not capable of using their judgment, whether they're working in pairs or whether they're working individually. A lot of it comes down to good judgment. So I've always seen continuous inspection and code inspection in this kind of way, the automated stuff, as being about the basic stuff, the basics, the bottom line. Where is the bar set? What shouldn't we let through? And the rest we leave to judgment. We leave room for maneuver, room for creative thought in software design. That requires skills and that requires knowledge, and that's going to be my final word on this, that for all of this, automated inspections and pair programming and code reviews and all of that stuff, ultimately, there's no substitute for developers who know what they're doing, who have, as Keith Braithwaite once put it to me, good taste in code. And that can be developed over time. It just needs education and mentoring and experience. A lot of developers never get it because they're never exposed to people who have good taste in code, who write maintainable code. But if you're in a position, and hopefully if you're watching this video, it means that you at least care about code quality, to learn about this stuff, then that's the ultimate last line of defense, is developers you can put your faith in, developers you can trust, not to write 1,000-line methods, not to write classes with 5,000 lines of code in them, and hundreds and hundreds of couplings, not to write nested if statements inside for loops, inside if statements, inside switch statements, and all that kind of nonsense that we know goes on. We've seen the code, we know it goes on, and we always wonder who thought that was fine. Well, the answer is lots of developers think that's fine. Evidently they do. Otherwise they wouldn't have written that code. So you need to mentor developers and mentor yourself. Spend a bit of time learning about and practicing code quality. If you've been watching these videos, that's a good place to start. And that, coupled with pair programming, coupled with regular code reviews, not for the purpose of actually testing code quality, but in order to explore and examine and reach a consensus on code quality as a team. And as the last line of defense, continuous inspection to stop the bad stuff getting through, which you could run at the very least on each check-in. But personally, I run it all the time because we're always missing stuff. There's always stuff we didn't notice. And that catches that stuff early when it's much easier to fix. So there you go. That's continuous inspection. I hope that's given you some ideas. If you're new to CodeCraft, then this might be some way off, but it's worth thinking about it, at least at this point. If you've been doing TDD and refactoring and et cetera, for a while, then this might be the next thing for you to think about or for your team to think about.